All right, good morning, everybody. Hope everybody's doing well today. Bunch of things to talk about. So, any questions before we get started? I'm going to talk about the midterm. I'm going to talk about homework 6 primarily, but any other questions first? Awesome. All right, so let's start with the midterm. So your midterm will be Friday morning at 11 o'clock. It will take the form of a Canvas quiz, which means you'll hop onto Canvas and you'll see an item labeled midterm. It'll be a quiz to take. I encourage everybody to be logged into Zoom during the midterm for a couple of reasons. One, if you have any questions, if something's not clear, you can send me a chat message on Zoom and I can get back to you about it. Number two, if somebody finds something like a problem in one of the questions, a typo, something that affects the ability to do a question, they may contact me about it. And if I find that there's a problem, I will send a message through Zoom chat and tell people, hey, question 3, this should be an X instead of a Y, right? If you're not in Zoom, I have no way of getting that information to you. And you may end up trying to do a problem that's impossible to do, or working under some misunderstanding or something like that. So hop into Zoom, but the quiz itself is on Canvas, okay? If something goes totally haywire, if you can't get into Zoom at all, you can't get into Canvas, something like that, try sending me an email to my regular email address, not my Canvas email, okay? Just shoot a regular email to me, and I will try to monitor that during the exam also. And then we can figure out what to do from there. All right, so that's logistics for getting into the exam. So the exam starts at 11. It's a 50-minute exam. It will close automatically at 11:55. So you got a few minutes of wiggle room in there, but time yourself to finish at 11:50. Make sure you submit it before you run out of time. It's set up to take multiple attempts, so if you hit the submit button early or something like that, don't panic about it. Just keep going, do the remainder of the questions. You can send me a note if you want with the submission, but if you do multiple submissions, they should all be available to me. Okay, but ideally, right, the final submission you make has answers to all the questions, but don't run out of time trying to do that. So it'll be this area midterm that'll show up. I'll get rid of this one in another day or two, and this will pop up. So 11 o'clock Friday, please don't miss your midterm. Let's see, for the quiz Friday, is it, we do it whenever and it's due Friday, we're joining a lecture, and then you were saying start the quiz, or is it replacing the lecture? Okay, yeah, so at 11 o'clock, just start taking the quiz. You don't have to come into Zoom, there's no lecture taking place, and the quiz is between 11 o'clock and 11:55 on Friday. If you come into Zoom, you can send chat messages if something's unclear, and I can send people clarifications through chat. But yeah, the quiz takes the place of lecture on Friday. So it's an honor system. Okay, I'm not going to use a lockdown browser or things like that because those are pretty easy to defeat. Unless you get really intrusive and monitor people's faces and backgrounds and all of this. Not going there. So we're just doing honor system here. The first question of the quiz will be an honor statement, and you'll be required to read that and then enter your name in an entry field to say that you agree to follow that. And the gist of the honor statement is you can use your notes, and your notes can be anything you've got written, any files that you have, old copies of code that you've done, your old programming assignments, things like that. Those all constitute notes, okay? And you can use the textbook. and you can use an editor to write your code, so you can copy and paste it into the entry area on Canvas, and that's it. So you're not allowed to do things on a Linux machine. You're not allowed to, you know, compile code and test it. You're not allowed to go to websites, talk to friends, chat, go to Chegg, etc., etc. Okay, so do your own work. You can use whatever you want for notes. The one exception, somebody asked the last period, if they have all of their old projects in Git, can they use their Git repository? I will allow that, okay? As long as you're only looking at your own code from your repository, that's okay. All right, so basically the situation that you would have if you were sitting in a classroom taking a physical in-person exam, except that instead of forcing you to print out, you know, all of your source code and notes and everything else, you can use that from a file on your system. But don't go back and watch videos, and don't go to any outside resources. All right, any questions on that? And that's all reiterated in the instructions on the midterm itself. So the midterm will be 4 programming questions and then a few short answer questions. The short answer questions are about Linux. And assuming you've been working from the command line in a Linux environment, you should know how to do all of these things. So editing a file, compiling multiple files, specifying the executable program's name when you compile, copying files, moving files, deleting files, making directories, changing into directories, seeing what directory you're in, initializing a Git repo, adding files to a staging area, committing files, pushing files to GitLab, stuff that you've been doing, okay? Make files will not be part of the midterm. We talked about make files yesterday. That's going to be on the final, but not on the midterm. So one section with a few questions on basic Linux operations, and then 4 programming questions, 2 Bash, 2 C. Okay. For the Bash programs, I'll remind you, and it reminds you in the beginning of the midterm also in the instructions, anytime you write Bash, you've got to follow the constructs that we've been talking about in class and that you see in the how-to on Canvas. Okay, which means the following. If you're doing arithmetic, you got to do $paren and put your expression inside there. If you use expr, if you use $single paren, etc., you don't get points. If you're using loops, it's got to be a while loop. You're not allowed to use for loops. Your while statements or if statements have to have the exact format we've been talking about. For example, while space, bracket, bracket, space, condition, space, 2 closing brackets, new line, do, new line, body of loop, new line, done. Okay. The conditions have to be one of 2 forms, comparing strings, equal, equal, or exclamation mark equal, comparing numbers, -eq, -ne, -le, etc., etc. Okay, it's all spelled out in that how-to. It's the only way we've ever written Bash in lecture, and it's the required way to write Bash code for this course. Once you're done with this course, you can do whatever you prefer in Bash. But for this course and for the midterm included, you got to use those constructs. So let me know early if you have questions about that. All right. So I've posted a practice midterm. Okay. You're going to be writing code, and writing code directly in Canvas I don't recommend. Okay, it's hard to format. If you accidentally hit a tab, it will take you out of your typing area, and if you hit a space, it'll click a button, and so on. So what I recommend, right, I have loud beeping outside. What I recommend is writing your code in an editor. Okay, don't use a code completing editor. You know, use Notepad, Notepad++, VI, Nano, whatever your choice is. Just a plain text editor. Write your code in there and then copy and paste it into Canvas. All right, that takes some doing. So this midterm practice, you don't have to do this. It's not, it doesn't count for any points or anything. But it's just a place where you can practice doing this copy and paste. So for example, question 1 just says write some code here. This is what your exam will look like. There'll be a description of something that you're supposed to do, and then there'll be an area for you to do it in. Now you can type, directly in here if you like. First time you hit a tab and you start hitting other characters, right, you risk losing all of your stuff. So recommendation, do your editing somewhere else. Okay. So for me, I like VI. Okay. But let's say you want to use maybe you like Kate. So let's say you type stuff in here. All right. So I've written my code. It's nicely formatted, right? And formatting is important. If there's a problem with your code and I can't easily figure out what you're trying to do, you're not going to get a lot of points. If it's written nicely like this and I can follow it, and maybe there's some comments in there and there's good variable names and things like that, and it's not quite right, there's a good chance you're going to get a lot of partial credit if I can tell what you're trying to do. All right, so I might copy this stuff, right, highlight it and copy it, and then I might come in here and I might say paste, and it's all slammed against the left, right? And that's not really great. So I might try pasting as plain text, and that's all slammed against the left. All right. If I come over here and I say pre-formatted, and then I come in here and I say paste, that looks pretty good. Okay. If I come in here and I say paste as plain text, that looks pretty good too. Okay. But it really depends on what your editor is. So so someone's asking about putty. Let's try a specific. Let me bring up. Now I'm running putty through a Windows emulator, which might change it, and it might have different settings. But let's try this. That's a big putty screen. Alright, so there's some nonsensical code. So I believe, let's see what happens if I just highlight it, and then I try to Control V. So for me, highlighting my text copies it. For you, you might need to do something else. That's why this practice quiz is here. Okay, and for me, if I copy this and I go to pre-formatted and I paste, that looks pretty good. Now if you use tabs, if you use spaces, this may change. Okay, if I use VI on my own Linux system, if I use VI on the Linux server, this may change. If I use PuTTY or I use SSH, if I'm running console or I'm running Termux, this may change. Okay, so what I'm suggesting is figure this out ahead of time. Don't wait until, you're partway through the exam, you've written your questions and you're ready to paste them in, and you realize that you don't know how to paste into Canvas. Figure it out now. Okay. Since somebody asked, let me take a quick look at PuTTY. So, and I can't make this well, I can make it a little bigger. If you go under behavior. So under selection, you can choose what you want the mouse to do. So I've checked this box which says auto copy selected text to the system clipboard. Okay, so that puts it on your clipboard when you just highlight text, and that's a whole lot easier than trying to find the copy and paste options in your menu and stuff. Okay, so mess around with this. Figure out what works for you. I don't think I have any questions like this, but sometimes you'll see questions where I give you code and ask you to make changes to it, in which case you might want to copy this and paste it into your favorite editor. So for me, I can Control-Shift-V, and that seems to work well. And then once I've got all of this, let's see, I make some changes here. I can highlight all of this, come in here, and if I Control-V, that seems to work pretty well. If I set pre-formatted and I Control-V, that seems to work pretty well, except everything is double spaced. If I do pre-formatted and I do Control-Shift-V, that's single spaces. Alright, but this takes some fiddling around with. Alright, please, please, please do this before Friday, so that you know how to do this. And you're probably going to encounter this in other courses. You're definitely going to encounter it in this course, and 215 and 222. So it's worth spending, 15-20 minutes to figure out your options here. And pre-formatted seems to be a big key. The other thing that may help in VI, if you say : set space expand tab, it'll replace tabs with spaces. Sometimes that makes it easier to format, because different systems interpret spaces differently. For example, this is really crazy indented here, right? It replaced my tab with 8 spaces, but it ended up way the heck over here on the right. So that's just a practice quiz out there. You can play around with it. You can take it as many times as you want. You can experiment. I don't look at this. It doesn't get graded. It doesn't count for anything. It's just there as an area you can play copy and paste with. All right, any questions on any of that? Yeah, that's what we've been doing actually, is playing with this fake quiz. So this is listed as a practice quiz, or midterm practice. So you can hit it right there. And it's just 2 questions you can copy and paste into. All right, any other questions? All right, so let's talk about your next programming assignment, which is homework 6. So this is posted on Canvas. It's a C programming assignment. It's due a week from Friday. So you have a little over a week to do this. Week from Friday, which is the 30th, 8 a.m., same as usual. And there's a big, long README that goes along with this. And that's posted on Canvas. But what I want to do is I want to show you what the program does. I want to run through some sample code, and then we'll go ahead and we'll look at this description of the assignment itself. But let's just start off by looking at what the program does. So there's a sample executable available for you. It's under /temp, and it's called main. Okay, and I'll leave that up there and available for the duration of the assignment. So you can run this and get an idea of what exactly your program should do. So let me go through this and show you some of the details, and then we'll spend some time actually going through the written assignment. So let me make a note. All right. So /temp/main. If you just run it without any command line arguments, it will invite you to play a high-low game. So this is a game where you're thinking of a number and the computer's trying to guess it. Okay. So it says, welcome to my high-low game. You'll be asked to think of a number, and I will try to think it. When I tell you my guess, please respond with H, L, or C to indicate whether my guess is too high, too low, or correct. And it says, please think of a number between 0 and 100. Hit enter when you're ready. All right. So who wants to think of a number? First person to pop on chat and say they want to think of a number. But don't tell me what the number is. Just say you want to think of a number. Okay, you're good. Person who just said, oh. All right, so think of a number between 0 and 100. Tell me when you're ready. Okay, so when you're ready, you hit enter. And the computer says, I will guess your number in at most 7 guesses. So guessed 150. So is 50 too high, too low, or correct? And we're going with Cole here. Yes, yeah, with you. All right, so is 50 too high? 50 is too high. All right, next guess is 24. Is 24 too high, too low, or correct? Too low. All right, guess 3, 37. High, low, or correct? Too high. Guess 4 is 30. Too high, too low, or correct? Too low. All right, guess 5 is 33. And that's correct. So the amazing computer has guessed your number in only 5 guesses. All right, thank you. All right, so this is your basic game. Okay, you're going to think of a number. It's going to try to guess what it is, and it's going to try to do it very efficiently. All right, and if you had picked a number between 0 and 1,000,000, it would be able to guess your number in 21 guesses. Okay, it's a very efficient algorithm. Whereas if you just randomly guessed, you know, it would take you on average 500,000 guesses maybe, or something like that. All right, so just type in the name of the program. It plays this game between 0 and 100. You can additionally specify an upper range. So if I say, you know, main 1,000,000, it'll say, please think of a number between 0 and 1,000,000. Hit enter when you're ready. Okay, well, I'm going to think of the number 17. Okay, so I'll say ready. So 500,000 is high, that's high. These are all, oh, I'm going the wrong way. Okay, so these are too high. I'm thinking of the number 17. And it said it could do this in 20 guesses, so it's used up half its guesses already. 14 is too low. 21 is too high. There's a 17, so 18 guesses, it figured out my number. All right, you can also specify 2 command line arguments and say, I want to play where we guess a number between 20,000 and 50,000. Okay, so it'll ask you to think of a number between 20,000 and 50,000, and it'll play the game accordingly. Yeah, that's the number I was thinking of. It guessed me in just 1 guess. All right, so 3 ways to run the program. No arguments, 1 argument, or 2 arguments. Okay. Error conditions, if you put in a negative number, if you put in a number that's not a valid integer, if you put in, you know, 10.0, not a valid integer, any errors in those numbers, you print a message and you exit. You don't ask them to put in another number, and so on and so forth. Right? 1020, haha, that's an error. 1010, that's an error. The second number has to be bigger than the first. First number has to be bigger than or equal to 0, so negative 10, that's an error. 0 is fine. Again, we're going to look at the spec for this. I just want you to see it once going through, and then we'll look at the written specification. once it's playing the game, right, so it always asks me to think of a number and hit enter. It doesn't just start guessing right away. It gives me a chance to think of a number, put it in my brain, and then hit enter. It starts guessing. My response here has to be either H, L, or C. If it's anything else, if I just hit an enter key, if I say correct, if I say space H, if I say uppercase H, those are not valid responses. Keep asking until you get a valid response. Okay, eventually I say, oh, that's high. Okay, now I can go ahead and make a new guess. It's always going to predict the maximum number of guesses it needs, and sometimes it will require that many guesses. Okay. It should also notice when the person is cheating. So let's say I'm thinking of the number 9. So I'll say 5 is low and 8 is low, 9. Well, I don't want to lose the game, so I'm going to say 9 is too high. It's going to know that something's wrong. Right? How does it know that? Because I already guessed 8 and I said 8 was low, and it guessed 9 and I said 9 was high. There's a problem, right? So it should notice when the person is cheating and let them know that and then exit. Alright, so that's the basic setup. This executable is here. You can always come back and run this to see what it's supposed to do in certain cases. So let's take a look at the actual assignment. Alright, so overview, it's a high-low game. It's got to be written in C. It's got to run on the Linux server. So the human is thinking of a number and the computer is trying to guess it. That's the first thing to be really clear about. Occasionally, when I've done something like this in the past, people code it backwards and the human is trying to guess the computer's number. That's not what we're doing here. Okay? You need to have the human think of a number and the computer has to try to guess it. Alright, so that's the first thing. There's a lot of detail in here. This is 4 pages. It's really important that we understand everything in the specification. Alright, your executable program must be called main, M-A-I-N. And anytime we're running this game, we're thinking of a pair of integers. I'm going to call these low and high for the sake of this discussion. And you're always thinking of a number between low and high inclusive. Okay? And there's 3 ways to run the program. If you run it with no command line arguments, the range is 0 to 100 inclusive. If you run with 1 command line argument, the range is from 0 to whatever that argument is, which means that argument must be at least 1. And if you put in 2 command line arguments, the range is from the low number to the high number. The low must be at least 0, the high must be at least 1. And the high's got to be bigger than the low. Okay, so some more examples. Main goes from 0 to 100. Main 25 goes from 0 to 25. Main 100, 200 goes from 100 to 200. Pretty self-explanatory, I think. If any of the integers that you specify on the command line are invalid, print an error message and exit. The game is done. Okay, don't go back and ask for new entries or anything like that. Don't make assumptions. Don't treat 2 space 5 as a 2, don't treat 25 haha as 25, etc. Alright, so the strict parsing of integers, meaning we're going to use that %d, %s stuff that we did last week, where you pick up extra stuff after the integer. Alright, if you have spaces in the beginning of a number, that's valid because spaces just separate command line arguments. Okay. Alright, so gameplay. Print out a welcome message. I'm making little notes here. Print out a welcome message in the beginning. Tell the person what the game is all about, that kind of stuff. And then ask them to think of a number. Okay? And tell them what the low and high range are. Okay? Ask them to think of a number. And then to hit enter when they're ready to start playing. Alright, so for example, if you say main 0, 200, say, please think of a number between 0 and 200 and hit enter when ready. Okay, I'm not worried about minor variations in this wording, but I want you to specify what the range is that they're thinking of a number between, and I want you to wait until they hit enter. Don't just go on and make your first guess before they thought of a number. Okay? Once the user hits enter, then tell them how many guesses it's going to take you. I will guess your number in 8 or fewer guesses. Alright? And then we begin a loop. So each time through this loop, your program should say guess number and show me the current guess number starting with 1, followed by the actual guess. Alright, so that's this business. I lost my terminal window. That's this business up here. Guess 2, colon 2. Guess 2, colon 8. Guess 1, colon 5. Alright, so show me the guess number, show me the actual guess, and then wait for the user to type HL or C. If they type something other than HL or C, ask them to type HL or C. Keep iterating until they put in a correct response. If they say the answer was correct, the game's over. You can thank them for playing if you like, and then you can exit. If the guess is too high or too low, the computer should adjust its guess, and then say guess number 2, colon, followed by the new guess. Wait for an HL or C. Alright, and keep doing this until it gets the number correct. The computer should detect when cheating is happening, and if the user is cheating, it should say, you know, that can't possibly be the case, and it should just exit. Okay? Alright, so here's the algorithm. There are a lot of subtly different ways that you can code this algorithm. Almost none of those subtly different ways will work in all cases. This will work in all cases. Okay? I'm giving you the algorithm. If you want to figure out how to do this yourself, I'm not going to discourage that. Okay? But if you're not sure how to get it to work, use this algorithm. And yeah, this is written in C. So I'm giving you everything you need to know about how to code this, right? So basically, we're always thinking of some range between low and high inclusive. You're going to make a guess which is low plus high over 2. And I'm just going to call that guess in here. If that guess was too high, change the value of high to be guess minus 1. If the guess was too low, change the value of low to be guess plus 1. And after you make that adjustment, if low is bigger than high, something has gone wrong. I.e. the user is cheating or they forgot their number. Alright? And like I say, there's variations you can do on this. There's other ways you can try to detect cheating. I think one time in the past I've seen somebody use a different algorithm and get it perfect. Okay? Countless times people have modified this algorithm, and inevitably there's test cases I run where it doesn't work right, and it costs points. So you got the code right here, right? You just have to change it into C. So let's see what this actually does. Let's say we're playing this game between 1 and 50. Okay, so I'm going to have this variable low, which is 1. I'm going to have this variable high, which is 50. And our first guess is going to be low plus high over 2. Well, that's actually 25.5, but if we do this with all integers, this will end up being 25. That's what you want. Don't do this with floats and try to round it yourself. Just make low an integer, make high an integer, make guess an integer. It will automatically truncate it, and this will be your first guess. Okay, and if you're in doubt, right, run the test code. Between 1 and 50, first guess 25. If you run your code and the first guess is 24 or 26, you're doing something different from the algorithm. Not necessarily a problem, but extra work for sure. Alright, so the first guess is going to be 25. And let's say I'm thinking of the number 35. Okay, so the program's going to say, is your number 25? So this is guess 1. is the number 25, and I'm going to say that's low. All right. If the guess was too low, change low equal to guess plus 1. This plus 1 is absolutely critical. If you don't do that, you can get stuck in infinite loops. Okay, if the guess was too low, change low to guess plus 1. 25 was too low. I'm going to leave high as it is. I'm going to change low. I'm going to change low to my guess plus 1, which is 26. And what I've done is I've cut my search in half. I'm no longer trying to guess a number between 1 and 50. I'm trying to guess a number between 26 and 50. Because if 25 was too low, I know the numbers 1 through 25, there's no point in guessing any of those. It's got to be at least 26, possibly as high as 50. So I've changed my low range. Okay? And then what do? You go back and you calculate a new guess. Okay? Set your guess to low plus high over 2. So 26 plus 50. And that's going to be 39. 38. So guess 2, it'll say is your number 38. And I'll say that's high. Alright, if the guess is too high, change the high variable to guess minus 1. 38's too big. There's no reason to guess 38, 39, 40, or anything above that. So I'm going to change my high variable to 38 minus 1, which is 37. And then I'm going to make a new guess, 26 plus 37 divided by 2. Wow, I made my calculations hard. 18, 13 is going to be 41. No. 26, 37, 18, 13, 31. Alright, so guess 3 is going to say is it 31, and I'm going to say that's low. Remember, my number's 35. Alright, 31 is too low, change low to guess plus 1. Change your guess to 32 plus 37 over 2, that's 69 over 2, which is going to be 34. So it'll say guess 4 is at 34, and I'm going to say, ha, that's too low. Well, that's too low. It's going to change my low to 34 plus 1 is 35. It's going to change my guess to low plus high divided by 2. That's going to be 36. It's going to say, is your number 36? And I'm going to say that's too high. And now it's going to say, okay, so I'll change my high to your guess minus 1, which is 35. Well, at this point, looking from outside, we know the game's over, because it has sandwiched down my number to something between 35 and 35. Okay? But don't do anything with that yet. Just keep playing the game. Make your guess. 35 plus 35 over 2 is 35. So guess 6 is your number 35. If I say correct, everything's great. Let's say I cheat. And I say, oh, 36 is too low. Alright, if that's too low, what's going to happen? I'm going to set low equal to guess plus 1, which is 36. Well, anytime that I change my low or my high, do this check. See if low is bigger than high. When it was equal, that's okay. That's not a problem yet. But low is bigger than high, I know something's wrong. The person has changed their number. So it's a really short main loop. Okay? Set your guess to low plus high. Ask how that guess is. If it's too high, change your high variable. If it's too low, change your low variable. And each time you change it, if low is bigger than high, game's over, someone's cheating. All right, so that's the algorithm. And it's a very efficient algorithm. It's basically log 2 because we're cutting things in half. So this is an algorithm that is called a divide and conquer algorithm, and we'll use this a lot in data structures in winter, CSE222, particularly when we work with binary trees. A lot of the algorithms we use on binary trees will be versions of this divide and conquer approach, and it's one reason trees are such an efficient data structure. So we'll be visiting this a lot down the road. This is also how we convert numbers from decimal to binary in Engineering 250. I'll leave you to think about that, but you're basically playing high-low when you do that. All right, predicted number of guesses required, 1 plus the log base 2 of 1 plus high minus low. I can't highlight, there we go. All of this. All right, so 1 plus the log base 2 of the quantity 1 plus high minus low. So if the person wants to play a game from, let me write this formula down. If the person wants to play a game where you're guessing a number between 1,000 and 2,000, how many guesses might it take you? 1 plus the log base 2 of 2,000 minus 1,000 is 1,000, 1,001. Okay, taken as an integer. All right, so how do you find a logarithm base 2? Well, do some math. Log base 2 of x is the natural log of x divided by the natural log of 2. We can do log base anything. We can do common logs if we want. How do we figure out logarithms? Well, there's a log function. And there's a few versions of this. There's log, which takes a double and returns a double. There's log f for floats, and there's log l for long doubles. We can just use a plain old log. Okay? But to use this, you need to do two things. You need to include math.h in whatever file you're calling log in. And then when you link, you need to say -lm at the end of your GCC command where you're linking things together. Okay? We're going to do selective compilation versus linking. So this would go in the link phase when we're linking the objects together. We would say -lm. And then inside your code, basically, take your high value, your low value, subtract those, add 1, turn that into a double, right? So either assign it to a double variable or cast it by putting double in parentheses before it. Pass that to your log function, take the result, add 1, and then change that into an integer. That's your number of guesses. And that should work correctly. If you find a case where that's not working, let me know, but I'm going to run with that formula anyway. And I tried this pretty extensively last night, and it seems to work. All right, sample executable on the server under /temp/main. Feel free to refer to that. Other requirements, this is the critical part. Okay, there's specific ways you need to structure your program. So think of this as, you know, a piece of a very large project at a very large soulless corporation, and you need to follow these requirements, and if they don't come out quite right, you're going to get in trouble for it. Your code's not going to work. It can be a friendly corporation. Let's work for Friendly Corp. But you'll have to do your code again. Do not round your calculation for the prediction. Just change it to an integer, which will truncate it. All right, so program requirements. You need to have the following files. A file named intro.c containing a function named intro, takes no arguments, returns nothing. That prints out your welcome message in the beginning of the program. Okay. You need a file called predict.c with a function named predict. Takes 2 integer arguments, returns an integer, which is the number of predictions that are required. And again, don't round your logarithm calculation, just change it to an integer, which will truncate it. All right, you need a file named getAnswer.c with a function named getAnswer. Takes no arguments, returns a character. This is the function that asks the user HL or C, waits for a response. If the answer is not exactly HL or C followed by an enter, asks the user again, and keeps iterating until they type in either H enter, L enter, or C enter. Whichever character they typed in, that gets returned as the value of this getAnswer function. Okay, and you got to have these 3 files with these 3 functions, and they've got to be named exactly like this. If it's getAnswer with a lowercase a, you'll lose points for it. Okay, this is nitpicky, I understand, but this is what happens when you're working on, say, a team, or you're working on something that's going into an automated system. So we want to be really specific about following the specification. Your main file should be called main.c and contain your main function. Okay, you can put any other code that you want in main.c, and I want at least one include file, main.h, that lists the prototypes for these functions. It can include anything else that makes sense to you. Okay, I also want a README file, which should have your name, the class, the date, a description of the program in your own words, and I want a make file. Okay, and the make file has to be a good make file as we described yesterday. Okay, so tactical compilation only compiles things that are changed as needed, and so on and so forth. It also has to include a clean target, and the clean should remove specifically the .o files that you need to remove to clean the project. Don't just do star.o. Definitely don't do star.c. If that's a typo, I'll fix. All right, Git requirements. You can have other .c files, you can have other .h files, that's fine. And you'll definitely have other functions. Your Git repository should have a README, a make file, and all of the .c and .h files needed, and nothing else. Okay? Don't put in object files, don't put in an executable, don't put in other .c files, don't put in test files, and so on and so forth. Just the stuff you need to make your executable program. All right, grading rubric. Well, we got 3 minutes left. Grading rubric. This is perhaps the most important part. Okay, if you write a program that plays high-low perfectly, it might only be worth 10 points out of 100 if you don't follow the rest of this. So this is not an exercise about making a high-low program at all costs. It's an exercise about following the assignment spec. Okay, which includes making a high-low program. Alright, executable must be named main. That's a function of your make file, 5 points. Program starts with the correct range when there's no arguments, 0 to 100, 5 points. Works with 1 argument, 5 points. Works with 2 arguments, 7 points. Handles all possible error conditions in the command line arguments, that's 7 points. If there's any case it doesn't handle, you don't get those points. Okay, so these are all or nothing. Prints a greeting in the beginning and tells the user what the range of numbers is that you're playing with, that's 2 points. Waits for the user to think of a number and then hit enter, that's worth 3 points. Predicts how many guesses it's going to take and tells the user that number up front, that's worth 10 points. For each guess, program prints the number of the guess followed by the actual guess, that's 5 points. Uses the correct algorithm for making each guess. That's the high plus low divided by 2. That's adjusting high or low based on the guess and whether the guess was high or low. That's 10 points. That's the actual high-low game. Okay. Notices when you say C and detects the game is over. Prints error messages and retries. If you don't type in HL or C, that's 6 points. Detects cheating. That's 8 points. And then these are about the structure of your file. So program is split into the required pieces, and you have the good clean make file as required. That's 11 points each. And then the Git repo has all the necessary pieces and no extra files. That's worth 5. Total of 100 points. Okay. Some of this, there's other things to take into account here. For example, if your code does not compile, you don't get points for most of this, right? You might get points for having it split into the correct number of pieces and having all those pieces in the Git repository, but you're not going to get credit for, you know, the program running correctly with 1 argument if it doesn't even compile and I can't get it to run, right? So make sure your program runs and then just go through these and make sure you get all your points. If you finish this project and you check off all these things and you're sure you got these right, you should end up with 100% on the assignment, right? And if you're not sure about something, ask me, okay? This is going to be an office hours kind of thing. This is going to get harder and harder to do in emails. But there's the grading rubric, right? So any questions about that, talk to me ahead of time, all right? Otherwise, I would love to see everybody get 100% on this. Okay, and here's exactly what you need to do to get 100%. All right, we are out of time, so so that will do us for today. I want to play some more with Git tomorrow, and then I want to start digging into some string processing along the lines of some of the things you'll have to do for homework 6. All right, have a good one. I will see you next time. Thanks.